Okay, so we're continuing our attempts to use the group axioms to verify that we have a group. In this problem, number 22, we look at the set of real numbers without the zero, and we consider the following product. It's A star B. If A is positive, then we just make it A times B, the usual multiplication. If A is negative, we do A divided by B. So very quick observation, this is not a commutative operation, right? The form depends on A, right? It depends on whether A is positive or A is negative, not on B. If we switched it around, it would depend on whether B was positive or negative. So definitely not going to be commutative. All right, well, let's see. What do we need to see? First, it needs to be a binary operation, which means, well, the output should be a non-zero real number. Well, let's see. In the first case, you're multiplying two non-zero real numbers. Okay, product of two non-zero real numbers, definitely not zero. In the second case, you're dividing two real numbers. Okay, they're non-zero, so again, it's not going to be zero. And of course, B is non-zero, so this makes sense. That's an important thing. So good, we have a binary operation on G. All right, how about associativity? Well, we're going to have to chug this thing out. We take three non-zero real numbers, A, B, and C, and let's consider this product. So first we'll do the B star C, and then comes the A. So this will be, well, there's two cases. It'll be A star. Well, in the case where B is positive, we just get BC. And in the case where B is negative, we're going to get A star B divided by C. Now, each of these two cases is going to break up further based on whether A was positive or negative. And to help us remember, let's write over the B, we said it was positive here and it was negative there. All right, so if we break this up into two cases, well, when A is positive, then it's going to be A times BC. So we just get ABC. So this was A positive here. And in this case, A is negative, or we're going to take A to be negative. We'll get, let's see, A divided by BC. So that's where A is negative. Okay, now in this situation, if A is positive, we'll get A times B over C. So AB over C. And so if A is negative, we'll get A divided by B over C, which is AC over B. That was where A is negative. Okay, now let's check when we reassociate. So we'll do A star B and then do star C. All right, so when we do this, if A is positive, we just get AB star C. And if A is negative, then we'll get A over B star C. Okay, well now we need to decide for the next one whether or not this whole quantity is going to be positive or negative. And it's going to depend on the value of B. So if B is positive, then since A was positive, the product is still positive, we'll just get ABC. So ABC, and that's where we assume B was positive. If B is negative, then AB will be negative, and so we'll get AB divided by C. That's where B is negative. Now let's quickly compare up at the top. When B and A were both positive, we got ABC, which is what we get here. And when A is negative and B is positive, we get A over BC. Okay, well, we have A positive here. Where do we have? Ah, there's A positive, B negative. We get AB over C. Okay, same thing. And now let's check the cases where A is negative. If B is, let's say, positive, then this whole thing will be negative. And so we'll do A over B divided by C, which is the same thing as A over BC. So that's where B was positive. And if B is negative, then this quantity is all positive, and so we'll do A over B times C, which gives us AC over B. Okay, let's check. So here we have A negative and B positive. All right, A negative, B positive, A over BC, A over BC. And here A negative, B negative, we get AC over B, A negative, B negative, AC over B. Fantastic, we have associativity. All right, so we've checked that it's a binary operation, we've checked associativity, now we just need identity and inverses. Alright, well, again, one could make a guess at what the identity is. You say, well, 1 is usually the identity, but let's see how you might actually think about it to get that as your result. So assume you had some identity element, E. You know that A star E should be A. On the other hand, you know that this is going to either be A, E, or A divided by E, depending on if A is positive or if A is negative. Well, if A is equal to A times E, then E better be 1. If A is equal to A divided by E, then E better be 1. So 1 is going to be the right choice for an identity element. Okay, let's make sure that it works in both directions. What if I do 1 star A? Well, 1 is positive, so we know that this is just going to be 1 times A, which is equal to A. Fantastic. We've got an identity element. Okay, to get inverses, we need to find something to star with A and get back to 1. Okay, fine. Let's see what it has to be. So, if I had such an element, we would call it something like A inverse. And when I star them, I should get 1. Now, if A is positive, then you know this is just going to be A times A inverse, whatever that number is. And if A is negative, then this will be A divided by A inverse. Okay, well, what number do I multiply A by to get back to 1? Well, it's going to be 1 divided by A. So, if A is positive, then A inverse really is the multiplicative inverse, 1 over A. What if A is negative? Well, if A is negative, then we need that A divided by A inverse should be 1. Well, what do we have to divide A by to get 1? A, of course. So I would tell you, for positive numbers, the inverse is the honest-to-goodness multiplicative inverse. But for negative numbers, the numbers are their own inverses. Okay. We better check the other direction. What if we did A inverse star A? Well, if A is positive, then A inverse is going to be 1 over A, which is still positive. So if A is positive, then we'll just get, well, that's positive, so we'll just do A inverse times A, which is going to be 1 over A times A, which is 1. What if A is negative? Well, if A is negative, then A inverse is equal to A. Well, it's negative, and so this is going to be A inverse divided by A. But A inverse is A, so you get A divided by A, which is 1. Fantastic. Inverses work. And so we have a group, and certainly not an abelian group.